Hello and welcome to the latest Hive tutorial. In today's tutorial we're going to be looking at how to create our own nodes and how to create our own workers and how to create an example system. So first things first, you should download this zip folder, which will be in the link in the description or on one of the many forum threads we have going. You need to extract it and you'll be left with a folder called start point, within which there is another folder called start point. Once you're inside that folder, you'll see that we have some example files. If you open up tester.blend, you'll see that we have some code in the code window. Long story short, this code is all we need to open up the output of the GUI, because the GUI does not output code unless you're editing the workers themselves. If you're editing the entire system, that gives out a web file, and we can load the web file and pass it so that it looks like code and we can run it ourselves. So now that we have our example file, if you press P in the console, you'll see that it does nothing. It loads and closes again. That's because we have not got a complete example map. So first things first, go into the Hive code base, which you should be able to, I'll create a new video on how to download, and you open up the GUI folder. Open up hive.gui.py in Python 3.2, and close the example window that pops up, but leave the console open. Now open up the test file which we have, which is desktop for me, and then it's in Hive example, start point, and tester.web. If we open it, we'll see we have two nodes. What do these do? Well, first we have the tick sensor. Now, if you look back into the code window, you'll see we have something called myhive and myhive map frame. Myhive map frame creates a hive from the web file, but that hive has no access to any of the Blender functions like the tick rate or errors and printing to the console, etc. So, in order to do this, we have another Hive, which is called Blender Hive, and this gives us access to all the Blender functions we need. We then run it. So now that we have the access to Blender functions in the GUI, you'll see we have a tick sensor, and this is part of the Blender functions that runs every tick. You'll see there are these red nodes. Red nodes are trigger nodes. Triggers are also circles, and the reason for this is that a circle is a push node, which means that it forcibly pushes the node next to it and tells it to do something. You don't have to use push nodes for triggers. They can be for data as well, but typically only a trigger can be a push node, or rather a trigger cannot be a pull node. So what does this do? Well, every tick, this triggers this transistor, and what a transistor does is it works like any other transistor in real life. When you put a current on the base, or apply a trigger on the base, it pulls the value into the input and pushes it out of the output, which means that this only tells the node it's connected to give its data through the input pin when it's triggered, and likewise it only pushes data out when it's triggered. That's where triggers come in. So we're going to create ourselves an example scene. First, let's go to I/O and get a display or a watch value, and in watch go into the parameters panel, and you'll see it says type_input. This is because watch is able to accept any data type. We're going to set that to string by typing str and click create instance. Now in the header, we leave that as what it is, so we don't need to touch it. That's just what it'll print in the console before the value. Now here's where the issue is. Watch is a pull variable. So in fact, we might be better off using display. So let's delete the watch. Sorry to confuse you all. Set the display to a string and delete the watch. Now connect the output of the transistor to the display and type in the header of the display value : and then you can put a space if you like. Now we need to put some data into this transistor, so we can go to std and take a variable. Set the variable type to string and connect the output pin, which is a pull output, to the pull input. The inputs and outputs have to match. A pull output means that it expects to have the other node ask it for data. Now we set the value to, let's say, hello, and now we're ready to go. So let's hit save, and we'll save this as our, if we go to, where is it, desktop for me, and it's Hive example, and start point, tester.web, save it. Now go to Blender and press P, and you'll see we have it printed to the console. Now let's get into something more complex. Let's create some game object nodes. How do we create game object workers? Well, we have to use the worker GUI. So let's minimize this GUI and go into the GUI folder of the code base and open up worker GUI. Now what we do is as follows. You see on the left we have segments. Unlike the other GUI, which if I bring it back up says dragonfly, segments are the components which make up a worker. So we have to have inputs and outputs normally. So let's give ourselves an input. This is going to get us a game scene. First things first, we have to be able to tell it the name of the game scene. So let's have a pull antenna, and it's going to be a string. Pull antenna string. We're going to call this, let's say, scene underscore name. So when you use the word this worker in the other GUI, you'll see that it has an input named scene name. And we click update ID. Now, antennae don't exist during the game runtime, so we need to output the value to something when it updates. This is like a matchmaker, so we need to tell it who to match the input with. We could do the following. We could create a variable string, and we could also take a transistor string, connect them together like that, and wait for it to be triggered. But that gives us two nodes. Instead, we can use something called a buffer. It should be a pull buffer, but I've used the wrong one. Pull buffer string. Now, well, that's the wrong one. Again, push buffer string. We need a pull buffer string, so like follows. What this means is that when we trigger or pull from this buffer, it copies the value of which is given by the other node through the antenna. Now, the point is that we're going to create this to give out a game scene. So, we need to create an output. And I'll explain more about the buffer later. Give us an output of pull output, but don't set the type, so just pull underscore output, and drag it over here. Now we're going to set the type to object, kx underscore scene. Object declares that it is a Python object, and kx underscore scene is just our way of telling it that it only outputs game scenes, and only other nodes that accept game scenes can use it. And we'll name this scene out. Now, we need to do the following. We need to be able to output the scene. So how do we get the scene value from a pull? This will try and pull the data from something, so we need to give it something to store the data in. So let's get ourselves a variable, just a variable, and give it the parameters type object, scene, no, kx underscore scene. This means it has the same variable type as the output node, which is useful because they'll connect if I can. There you go. Now, let's name this scene object, or scene obj. Now, how pull nodes work by being asked for their value. So where do they get triggered? Where do we get the triggering to get all the code to work? Well, if you click on this scene obj variable and change the view to full, so we have lots of different triggers. We want to use pre-output. In other words, we want to modify the scene variable before it outputs to get the variable from the pull buffer. There are two ways of doing this. You could show the full view on the buffer and connect the update pin to the pre-output. But then this would only be able to output a string if we connected the output to a transistor into this. We want to be able to output a scene. So to do this, we're going to run some Python code. Then to run Python code, you need to use a modifier. Here we have a modifier. If you go to the parameters, you see we can type code. First, connect the modifier trigger to the pre-output, which means that before we output our scene to the output, we need to first set the scene value to this variable here. And to set the scene value to the variable, we need to set it before it updates or before it outputs using the pre-output trigger. Now, we're going to use this modifier to run some code to get the value of this scene name, which is also a pull. So how do we trigger it? We can either use the trigger pin here, or we can use the trigger func. And we'll create a function name that will be used to trigger this buffer. So we're going to call it getName. Okay. Now go into our modifier, and first you'll see we can type some code. So we're going to have to import the BGE to get the scene, as you do normally. Now we're going to have to update the value of the scene name. So first rename our buffer to scene name var. Copy that name, scene name bar. Now go into our modifier, type import BGE. Now self dot get name, and we'll run it. Now the problem with this will update this variable or buffer from the input. But what if someone doesn't connect it to anything to the scene input because we want to get the current scene, so it would make no sense to type the scene name in. we'd have to catch the exception. And to do this, we do the following. We first must create some special try and except statements. So first put this into try and use 4 spaces. Now, we'll get the variable which is stored from the input, name equals self.scene name var. Now get the current game scenes equals s.name colon s for s in eg.logic.get scene list. Now what this does is it gets the name of the scene and maps it to the scene itself in the scene list. And now we can say that the scene that we want equals scene's name. What if we don't have anything connected to the input pin? Getting the name won't work because it's not connected, it'll throw an error. So we need to catch this. So put except pull input error. But wait, there's another error, which is if the scene name is wrong. So we have to put these in brackets, put a comma, and put key error in case the name doesn't exist. And we'll set the scene as the current scene. That's by default. We'll also make it print an error statement. Print scene specified doesn't exist. Now we can go and carry on. We need to output the scene that we've got up here, or up here. So how do we output it? Very simple. We first set the output variable to this value, so self.scene obj equals scene, and now we trigger the sending. How do we trigger the sending? We don't, because we're done. I made a mistake there. We don't need to trigger the sending because once the modifier is finished running, it will then output the value. So hopefully this works. This was very fast, so I apologise. So we'll now generate the code. Go to Generate tab and click Generate. And copy this. What do we do with this? Very simple. It's probably best that we save the output first. So close this. Go to File, Save As. And in our folder, which is, for me, Hive example, start point. If you go to the workers folder and we want to create get scene.workerweb. You can use any extension you like. Now we generate the code. Hopefully it will work. Sometimes it does throw errors when you try and generate code twice. I will try it once more. In this case it hasn't worked, so I've saved the node. I can close it, open up the GUI again, worker GUI, file, open, and I want to go to Hive example, start point, and workers, and then get scene.workerweb. Now we can generate this, and you'll see it should have renamed it to the proper worker name. Don't worry if you don't understand this, we'll get to the basics in due course. Copy this code, now open up a text editor, which I have right here. Paste it. I'm just going to quickly check that these match my pre-coded one. We have most of the things we need. And now I'll save it, File, Save As, Desktop, Hive example, start point, workers, and we'll call this get scene.py. So now we can use our worker. So if we go into the Hive GUI, and we'll save this again. In fact, click create new, and then we'll save as back in our folder. The reason for this will come through in a minute. Start point, and then we'll open tester.web. I'll save as tester.web. I'll close it. And oh dear, it's crashed. And then open it up again, Hive GUI. File, open. desktop Hive example, start point, and then test.web, you'll see we have a new folder called workers, because it has our custom workers in it. And if you go into, we see we have a get scene worker. If we drag it into our scene, we'll see we have the following: get scene name and scene output. We can take in a scene name by going to Dragonfly and creating a variable, which is in standard variable. Set the variable type to string in the params, connect it, and this will output a game scene. But we can't use this game scene because there's nothing that uses it yet. So now we have to create a get object worker to get an object from the scene, which is all part of the next video.